Hi, this is Lukas, and I'm welcoming you to the session Sharing Clusters, Learnings from Building a Namespace on-Demand Platform. As I said, my name is Lukas. I'm the CEO of DevSpace Technologies, Inc., and I'm currently working on Loft.sh, which is essentially a multi-tenancy solution for Kubernetes. I'm also an open source maintainer for several Kubernetes-related projects like DevSpace and Kiosk, a project which you will hear about in a couple minutes. I just recently relocated to San Francisco. Yeah, one of the few people that actually moves that way and not out of the Bay Area. You might hear the funny accent because I'm originally from Germany, so excusing for that right up front. So who is this talk for? This talk is essentially for IT teams, admins, and SREs at companies that are already managing Kubernetes clusters. Might be for production, CI/CD, staging environments, or whatever. And who now want to make Kubernetes available for engineering teams. That means you plan to host multiple engineers or engineering teams in shared development clusters. So we're talking about the pre-production stage in this talk. And the challenge here is really about Kubernetes multi-tenancy and getting the experience straight for your tenants in large shared Kubernetes clusters. When we talk about multi-tenancy, well, we first have to understand what that means. So essentially, single-tenant Kubernetes clusters are clusters which you hand over to a single team, which you're running singular workloads in, and multi-tenant Kubernetes clusters are essentially larger and shared Kubernetes clusters, which host a variety of engineering teams and their workloads. So once we compare those two approaches, we can very quickly understand that single-tenant Kubernetes clusters can be very expensive because you're creating a bunch of Kubernetes clusters and someone's got to manage them. You have to essentially pay the cloud computing resources for all these clusters. It's really hard to scale things to zero. So single-tenant Kubernetes clusters tend to be pretty expensive, whereas multi-tenant Kubernetes clusters are cheaper, but very difficult to get right. And that's what this talk is about. And to be more specifically, this talk is about soft multi-tenancy. What does that mean? So essentially, if you're kind of looking for hard multi-tenancy, you're looking at systems where there's zero trust between tenants. That means, for example, if you're running like a platform as a service offering, and you have multiple users from different organizations who you don't even know potentially, then you're talking about a hard tenancy that you might need for your platform. We're talking about soft tenancies. So typically your tenants are users all from the same organization. And there's a small chance of malicious actors from the outside of the organization. So it's mainly really about preventing accidents and ensuring the stability of the underlying platform rather than hardening against outside attacks. So let's get to the first learning that I discovered while implementing multi-tenant Kubernetes clusters at a variety of companies over the past 2 or 3 years. The first learning is essentially centralized user management and authentication. You probably already have users in a third-party system like Active Directory, Google, or Microsoft if you're using like Office 365. GitHub, GitLab for sure are systems that are aware of your engineering teams. And you can simply hook up an open source project called Dex to your platform. It actually recently became a CNCF sandbox project. And with Dex, you can achieve single sign-on for Kubernetes. Dex is an OpenID Connect in OAuth 2 provider, and it supports various identity providers, including LDAP, SAML, and obviously Google, Microsoft, GitHub, GitLab, etc. So it's a very powerful tool to get authentication right. So, for example, you could provide a kube config, right after a user authenticates through the Dex authentication workflow, and let the user, in the simplest case, just download a kubeconfig file, right? Obviously, that can get a lot more fancy, if you have your own CLI tool, which creates kubeconfig files on the user's machine, and does the authentication workflow for the user automatically, right? Just pop up the browser and have them redirect to a localhost port that the CLI opens. There are different levels which you can do, but the most easiest one is just redirect users to Dex and let them download a kubeconfig file at the end. The second learning is essentially you want to restrict users. Obviously, you want to ensure the security of your platform, so you need things like pod security policies for sure, because you don't want any privileged pods being created out there. But at the same time, you really need to make sure that you use smart defaults for your platform, because UX really matters. Because if you're providing a Kubernetes offering to engineers, you really care about the adoption of your platform within the organization. You want users to actually have a pleasure in using Kubernetes. So let me give you an example. Definitely you want to set resource quotas and you want to limit users, regarding CPU and memory, etc. But if you do that, then users must specify CPU and memory limits within, all their pods and containers. But they might not want to do that in the early stages of development, right? And they shouldn't have to worry about that too much, to be honest, because it's development stages, pre-production. Obviously, you want to have all these limits configured in production and staging for sure, but might not want the engineers to worry, the first thing they worry about shouldn't be this. So set defaults and then let Kubernetes implement them via limit range. It's a standard Kubernetes construct which you can use here, and essentially it's a mutating admission controller which is going to apply these defaults to all pods who do not specify CPU and memory limits. Test it out with various workloads of your engineers and find the smart defaults for your organization. Network policies you definitely want to have in place as well, because you don't want some network traffic go all across your cluster here. So probably you want to apply like the default deny all policy, but then you want to open up certain things. Definitely you want the user to be able to communicate within their namespace, right? Certain ports within their namespace service should be able to interact with each other. You want to probably, for a lot of containers or a lot of namespaces, you can do this with labels, for example, allow them to connect with the internet. And don't forget about DNS as well. Usually you want them to connect to your cluster internal DNS, but you can also let them use any outside DNS service as well. The third learning is essentially automate as much as possible. And it applies to everything I was just talking about. And additionally to RBAC and everything related to that. Create templates essentially for anything. You might want to use Open Policy Agent, which is also a CNCF project for dynamic admission control. Because there are certain things you can't enforce with standard Kubernetes rules, but OPAC can do them for you very easily. So for example, hostname validation for your ingress resource. You don't want colliding host names and having your ingress controller kind of like, do some kind of load balancing between different tenant applications. You want each tenant or each namespace or whatever, you define a single unit here to have a certain set of, subdomains or whatever that they can use, and they should follow a certain pattern, right? So you could have like a suffix or a subdomain of that includes, right, the tenant's name or the namespace name or things like that, right? And OPAC can really check this and, essentially reject anything that doesn't follow this pattern when someone's creating an ingress. It's pretty easy to implement that. Additionally, you can use the same hostname validation for the certificate resource if you're using things like Cert Manager, so that your Let's Encrypt account doesn't provision a lot of names, a lot of host names which aren't actually being used in your system. And then you might want to restrict certain storage and network related configurations. You might not want every user to provision load balancers in your AWS account. You might want to set some restrictions there, because you may want to provide some certain, cluster-wide services so that not everybody needs to install their own ingress controller, cert manager, etc. Provide these services and automate them as much as possible for yourself. If you're setting up new clusters, you can use Terraform for that, or just a simple Helm chart, which you have Helm dependencies to Nginx ingress controller and cert manager, things like that, and really bundle your configuration there. And related to that, I would really recommend to store everything in Kubernetes. So I would have no state outside of Kubernetes, so no like database where you keep track of certain relationships, etc. And potentially you want to also store things in Git. So use Kubernetes-related, Kubernetes native resources like, annotations, labels, secrets. All these constructs are really great to store information about owners and tenants, what they can do within the system. And the great part about this is you can also use GitHubs now to kind of manage the state of your platform. That means you get a free audit log via the commits. You can roll back very, very easily. You have an automated approval process, right? That's really great. So let's say you set up a very easy system for provisioning namespaces. And the easiest system is to have something like Flux, running in your Kubernetes cluster. And it essentially pulls the state of your Git repository and applies it to your Kubernetes clusters. That means you could, for example, tell the user, hey, if you need a new namespace, create a pull request, and we're going to approve that for you. And, certain limits for your for this namespace or whatever could be, annotated, or there could be labels, or there could be in a config map that the user also needs to add to this pull request. And then you can use all Git-based features for a very easy approval process with all the power that, GitLab, GitHub, etc. provide for you. This is great for, keeping track of your platform state, but it's not so great to keep track of your user workloads, right? I would argue that engineering teams should have direct access to Kubernetes rather than having to go through, CI/CD, GitOps system or whatever to deploy something to Kubernetes. If they see some tutorial out there to install a Helm chart that they might need for their, day-to-day work and want to try it out, right? They should be able to follow that tutorial and not have to, adapt to a different workflow, etc., which makes it just more complicated. So keep your platform state in GitOps, but that doesn't necessarily mean you also need to keep your user workflows and everything that's related, to their work into Git as well. And if you want even more control over what's happening in your cluster, you can always write a controller, introduce CRDs, custom resource definitions, and kind of extend Kubernetes. Tell Kubernetes, this is a tenant for us, for example, right? And those are the tenant limits that could be objects in your platform that you're creating. And if you're going extra fancy, you can even write an API server extension to solve the list problem. The list problem essentially means you can set RBAC to get users to perform kubectl get on their namespaces, right? But they have to provide the name of the namespace. If they want to run kubectl list namespaces, it's either all or nothing, right? They can either get access to all namespaces and list all of them, or none of them, right? You can solve that by an API server extension and essentially filter the namespaces that a tenant has. And one project I was mentioning earlier that I've been working on for a couple months now, I think we open sourced it in February, is Kiosk. Kiosk is an extension for Kubernetes. It provides an API server extension and several CRDs for multi-tenant Kubernetes clusters. If you go to kiosk.sh, you'll be redirected to the GitHub repository, and the README contains a lot of walkthroughs and explanations about how to configure Kiosk and how to set it up in your cluster. It's essentially as easy as installing Helm chart. And then you have like a tiny controller running in your system, as well as this API server extension. And then you have resources available that users can work with or that you can use to start building a multi-tenant Kubernetes platform. So one of these resources that solves the list problem is Space, for example, right? Space is entirely virtual. It's not a CRD. It's not persisted in that way. It's an extension of the Kubernetes API server. And if the user runs kubectl get spaces, right? They essentially only get those list spaces, sorry. They essentially only see those namespaces that they actually have access to via RBAC, right? So where they essentially have the permission to read pods or whatever you configure in Kiosk. Kiosk also knows templates. You can use those templates essentially to tell Kiosk, hey, when one of our tenants creates a space, kubectl, creates space essentially, apply certain templates to it. And that can be, RBAC rules, network policies, limit ranges, whatever you may need for your multi-tenant Kubernetes cluster. It's great because Kiosk does that automatically for you. Obviously, if you're going with the GitOps approach, you might not want to have templates, instead rather force the user to include that in the pull request. But either way, it's going to achieve the same state. And then there's essentially the definition of a tenant, which Kiosk calls account. And you can set certain account quotas, which essentially limit an account. And if you want to learn more about Kiosk, reach out to this guy. Fabian is a Kiosk maintainer and really the brain behind all of this. We launched the project together, but if you really want to, dig into the details, you should definitely talk to him. And if we're looking at the workflow in Kiosk, there's essentially two personas, right? There's you as a cluster admin, and then there's the account users, which can be a regular Kubernetes user or a Kubernetes group or a service account, right? And you essentially define and manage accounts and account quotas as well as the templates, right? And then users use their account to create spaces. And when they create a space, they essentially, define in the spec that it belongs to this account. And then when they do that, the admission controller will essentially check, hey, the API server extension, will actually check, is this subject or service account who is ever doing the kubectl request, who is it? Is that person actually, that user actually part of this account? Will I allow this, right? And if the space is being created, it will create the underlying namespace and enforce the templates that you have enforced for this account, right? So now we got kind of the basics set up regarding authentication. We automated a lot of things. We restricted our users, and we might even use Kiosk, kind of to get this, kind of structure for our multi-tenant Kubernetes platform. The next part is really about how users interact with the system. I would argue, do not hide Kubernetes, but try to make it as easy as possible for users to use. So engineers actually need access to Kubernetes, so they need to run kubectl commands, etc., because they want to, verify new features very, very fast. They don't want to have to go through the full CI/CD cycle just, when they see something that they might need, some Helm chart they want to install, or if they want to just test a new feature very quickly. They want to do those things pre-commit, right? And they want to debug the container startup, inspect the state of the applications, attach debuggers, and trace requests between several microservices that they might be working on. But I would also argue kubectl is just an API client. It's not really a developer tool, right? So you should tell your engineers, hey, use kubectl. You have the full power, right? You can also use Helm or any other Kubernetes tooling, and leave up the workflow and tooling to them. But I would definitely recommend, as you're more of a Kubernetes expert than most of your engineers will be, to raise really awareness for open source tools which are out there. You can vet them with your engineers and essentially, give them a list and say like, hey, here I found all these tools that work really great. I would recommend you take a look at them. I'm just going to name a couple down here: Scaffold, DevSpace, Telepresence. They're all pretty similar, but there are two distinct differences. So Telepresence is the bit older tool, which essentially assumes you want to work on a couple of microservices. The one that you actually want to work on should run on your local machine. Everything else is being deployed to your Kubernetes cluster. And what they do then is they start like a two-way proxy between the local CLI and a Telepresence pod that runs inside your cluster. Then you can, with the CLI, also mount, this network proxy, and volumes even from the cluster and things like that, so that your local service kind of feels like it's running inside Kubernetes, although it's running on your local machine. That has certain drawbacks, but has a big advantage that it feels, from a developer perspective, I mean, everything's running locally that you're working on. That feels really great. But it's kind of bad on Windows still. The network can get pretty slow. If you're always doing this proxy network, really depends on your internet connection, and you might have issues with volume mounts. But generally, I would really recommend to check out Telepresence. The other tools pretty much follow this workflow. That means the developer uses a CLI tool to run a local kind of CI/CD pipeline that builds images, tags, and pushes them to the registry, starts port forwarding, and to everything that has been deployed to the cluster. And here, everything gets deployed to the cluster. So unlike Telepresence, where one service runs locally, everything runs in Kubernetes now. And to get this hot reloading experience, so that the developer can still code with their IDE, save a file and see the changes, they typically tend to have file sync, which synchronizes files from the local file system to the container file system. And then the only thing you have to do is, install for development a special Docker file, for example, with which adds a hot reloading tool inside the container, and maybe remote debugger, things like that. Might be a bit, might take a while to get used to this. An engineer needs to play around with this like 10 minutes, but it's definitely easier in the long run than maybe the network complexity of Telepresence. Let's get to learning number 6. When your platform is actually up and running, you should really care about cost as well for the sake of the organization, and really shut down idle workloads. So the first thing you want to do is enable auto-scaling whenever possible. If you're pub cloud, that should be pretty easy. If you've done a great job with your platform and the UX is great and engineers are actually using it, they'll be really quick to spin up and deploy a lot of things, right? But they'll be terrible at turning things off. So you should really try to automate the shutdown of idle namespaces or idle workloads in general. So I'm just going to recommend a couple of tools. There's a fairly new tool called Cluster Turndown by a startup called Kiosk, which you can use to set up a fixed schedule when to turn down your EKS or GKE clusters. So you can essentially say, hey, at 8 p.m., turn everything off, right? Scale it down to 0, kill all the nodes, right? That's pretty hard. But obviously, it's doing the job in terms of saving cost, right? And then in the morning, spin up everything again. Obviously, you kind of adapt to the schedule of your engineers here. If you're based on OpenShift, you can use idling in OpenShift, which is essentially network-based shutdown. So if OpenShift doesn't detect any network requests for a while, it can, scale down replica sets automatically to 0. And then engineers can just, turn up the replica sets again. And then in Loft, which I'm currently working on, you have a feature called sleep mode, where you can essentially make that decision not on pure network traffic, but on API server requests. So you can tell Loft, hey, if the engineer hasn't done any requests to a specific namespace in the past 20 minutes, shut it down, right? Shut down all the replica sets or turn the replica sets to 0. And as soon as the first API server request comes in, reset the replica sets to whatever they were beforehand. And then last but not least, learning number 7 is sometimes users just need more than a namespace, right? I was talking earlier about single-tenant clusters versus multi-tenant clusters. If you have a single-tenant cluster, it's great. You essentially become the admin of the cluster. As a user, you can do anything, set up RBAC, a lot of Helm charts need you to, set up certain RBAC rules. You might not want your users to do that in a multi-tenant Kubernetes cluster. So namespaces have certain limitations. What's with, custom resource definitions? Will you be able to let your users install CRDs? Probably you don't want to do that, right? Helm charts use certain RBAC permissions. What if your users want to enable certain Kubernetes alpha or beta features or want a different Kubernetes version? You can't do that with namespaces, but you can with a construct called virtual clusters. And virtual clusters are really kind of Kubernetes clusters that run inside another Kubernetes cluster within a namespace, right? So if you let users provision those, we really unlock access to cluster-wide settings for those users. They can do whatever they want with their virtual cluster. They provide better isolation than namespaces because they host a separate Kubernetes control plane, right? There's a separate API server, which is also great from isolation, security, and stability perspective. And then additionally, because they're not true isolated single-tenant Kubernetes clusters, they're virtual clusters running in the same host cluster, you can also do kind of like a sharing of resources that run in the host cluster. For example, services like Nginx or Cert Manager, right? You just need to run them once, and you can kind of hook up the virtual cluster to those host services as well, which provides similar efficiency as namespaces. If you want to learn more about virtual clusters, you can either check out what the multi-tenancy SIG is working on, or you check out what we've released just like a couple of weeks ago on github.com loft-sh virtual-cluster, which is essentially an implementation of a virtual cluster. That means we're starting like a K3s cluster within one of your namespaces, and then have like a syncer which syncs certain resources to the host cluster, right? To actually, start pods and containers, etc. But we have like entirely the logic, RBAC, etc., encapsulated into one namespace that is hosting the K3s cluster. So I encourage you to check that out if you are kind of hitting the limitations of namespaces, but that's pretty far down the road. And I'm sure you'll be busy with, the first 6 learnings so far. Just to recap, here are all the learnings that, kind of I took from creating, several, implementations at different sizes of companies that wanted to host multi-tenant Kubernetes clusters. And if you want to dig into one of these topics like in more detail, just head over to one of these links I'm attaching to the presentation. There was a really great talk of James Wen, an engineer at Spotify at last KubeCon, and there's a lot of great articles out there. And I really urge you to also check out what the SIG multi-tenancy is working on. And if you have any particular questions, to Kiosk, whatever I'm working on, or to any of these learnings, don't hesitate to reach out to me. And I'm also going to be available for Q&A, and I think we have about like another 5 or 6 minutes for this. So if you have any questions, feel free to ask them right now. Thanks for your time.
All right, so that was the main presentation. I'm happy to answer questions. So if you have any questions, feel free to open the Q&A button on the bottom and just type in your question. We already have a couple of questions that came in a few minutes ago. I'm just going to read them out loud and try to answer them in the remaining 5 or 6 minutes that we have left. The first one is, what do you think about using OPAR and check config maps with that? You see some bottlenecks here. So a lot of companies that my team and I have been working with are actually using OPAR. It's a really great project. Really allows you to add additional, really flexible security rules to your multi-tenant cluster. So I definitely recommend to check out OPAR. It's super, super useful for multi-tenant clusters. Does Kiosk have a graphical user interface? Kiosk as an open source project is kind of like a basic building block to create soft multi-tenancy in Kubernetes. So it teaches Kubernetes certain CRDs that are required, like what is a tenant, what is a account, what is a space, things like that. But it doesn't have a GUI. So if you need something on top of that, you can obviously build that, just using kube context. If you're using Loft, the project that I'm working on right now, it's using Kiosk internally. So whenever you connect the cluster, installs Kiosk, and Loft ships with a graphical user interface. So if you're interested in that, just install the Helm chart and try it out. What is your experience, suggestions regarding the usage of CRDs in a platform as a service based on managed Kubernetes clusters? And then the person asking these questions is referring to issues with the cluster-wide scope of CRDs. Yeah, that's what I mentioned at the end of the talk, essentially. So namespaces are kind of like the basic unit of, sharing multi-tenant clusters. And namespaces have certain limitations because obviously you don't want users to install CRDs on a cluster-wide level after you set up, RBAC, etc., to restrict them to a certain namespace. So virtual clusters is really something you should look into if you want your users to actually work with CRDs, because in virtual clusters, users can essentially create cluster-wide cluster scope resources, which can be super helpful. For soft multi-tenancy that requires, certain users to deal with RBAC rules, install things like controllers and CRDs. Even if your users are developing controllers, right, that is definitely something to look into. The next question, solutions like virtual cluster and Kiosk seem like a very nice approach towards multi-tenancy. Would you classify these under soft or hard multi-tenancy? And what is the roadmap towards a version 1 production-ready version? So definitely soft multi-tenancy. If you want hard multi-tenancy, you need to look into, like really making sure that users are not sharing the same kernel, things like that, or that they, there's like virtual kubelet, things like that, where essentially your containers end up on different VMs, right? Things like that are definitely more towards hard multi-tenancy. Virtual cluster and Kiosk is really for soft multi-tenancy if your engineering teams are supposed to share the same Kubernetes clusters. Regarding production readiness, both Kiosk as well as virtual cluster have been used by a variety of companies of different sizes, from small companies of just like 10 engineers sharing a cluster up to 100 engineers sharing a cluster. Obviously they're pretty young technologies, so there's not companies out there using it with like 10,000 engineers working in the same cluster, but I actually think that would probably not make a lot of sense for companies, because you might want to split up things in different geographical locations, etc. I don't think you want your European engineers working in the same cluster as the ones in North America, for example, right? So you're going to have several clusters that you share, and then 50, 100 engineers, maybe 200 engineers may share a cluster, but probably not 10,000. However, as I said, both projects have been used in production, if I may call it that way, for the development use case. We're also evaluating both technologies for actually production workloads, but that's something we can I'll talk about in the Slack channel. So feel free to ask any questions there as well. Might not be able to answer all the questions here. Maybe one last question. Sometimes I feel the need for nested namespaces or grouping multiple namespaces into one logical bigger namespace, Is that something you consider useful for multi-tenancy? Definitely. I mean, the multi-tenancy groups working on something like that. I also believe that Google has shipped something similar for GKE right now, where you can essentially build these hierarchical namespaces. However, I think, virtual clusters offers more possibilities than just nesting namespaces, essentially. But in the end, it does the same thing. So in the end, everything you do creating, namespace in your virtual cluster are actually going to end up in the same namespace on your host cluster, right? So you're achieving a similar goal, but with a different layer of abstraction and maybe more, freedom and flexibility for your users. And as we only have like a couple of seconds left to end the session, I just want to take the time to thank you all for listening and watching the video online. And the slides will be online. I think on the scheduling website. I can also post them in the Slack channel again. And if you have any questions, feel free to reach out anytime. Have fun and enjoy the rest of the conference. And thank you for tuning in.